This lesson is over sequences. An arithmetic sequence, or an arithmetic sequence, is a list in which each term is found by adding the same number to the previous term. So for example, 1, 3, 5, 7, and 9, each term is found by adding 2 to the previous term. So we're going to practice by describing the relationships between the following arithmetic sequences. So from 17 to 23, we are adding, oops, always forget that pen. We are adding 6. And from 23 to 9, we are adding 6. And from 29 to 35, we are adding 6. So each term is found by adding 6 to the previous term. Then, plus 3, plus 3, plus 3. So each term is found by adding 3 to the previous term. Now I'm just abbreviating this next one because I've already shown you the expectation for how you should describe this. That should be the same thing for number 2 as well. I'm just abbreviating it so the video is not so long. On the next one, we're adding 12, 12, 12. So the pattern here is that each term is found by adding 12 to the previous term. In a geometric sequence, each term is found by multiplying the previous term by the same number. So times 2 times 2 times 2. Each term is found by multiplying the previous term by 2. So on example 4, we're multiplying by 3, by 3, by 3. So each term is found by adding 3, multiplying the previous term by 3. So this is the expectation of how you should describe this, and I'll abbreviate for the next ones. So we're multiplying by -2. 4 times -2 is positive 8. 8 times -2 is -16. So all of these are being multiplied. So each term is found by multiplying the previous term by -2. The last one is times -1 times -1, because 1 times -1 is -1. -1 times -1 is +1, and so on. So each term is found by multiplying the previous term by -1. You can also write a rule or an equation for a sequence. This rule can be used to find the nth term value in a sequence. So for example, the position, we call that n. And it can either be in the first position, second position, third, so on and so on and so on. And then the value of the term is what it actually ends up being. So first we need to figure out what is our pattern. We are adding 3 each time. Once we add 3, what that is telling us is that every time we go to a new position, that's the amount it's changing by. So when we write our rule, that's what we multiplied our position number by to get our answer. So 3 times 1 should give us 2. However, we know 3 times 1 is not 2. So what do I have to do to 3 times 1 to make it into a 2? Well, I subtract 1. Now 3 times the second position should give me 6, but it doesn't. It gives me 5. So that means I've subtracted 1 from this process to get my 5. 3 times 3 should give me the number that is in the third position. 3 times 3 is 9. That is not the number in this position. So I have to subtract 1 to get there. 3 times 4 is 12. I subtract 1 to get there. 3 times 5 is 15. Subtract 1 to get there. So what that's telling me is that 3n minus 1 equals my value. So my value equals 3 times the position n minus 1. In this next one, each of these terms are increasing by 10. So if I multiply 10 by the position, it should give me my answer. 10 times 1 is 10, but it says that the value is actually 8. So how do you get from 10 to 8? You subtract 2. 10 times 2 is 20, but it says my value is 18. So again, I'm going to subtract. 10 times 3, 30. Subtract 2 to get to my actual term. 10 times 4, again, it's a subtract 2. 10 times 5, that's 50. Again, subtract 2. So that means my value is going to equal 10 times the position number minus 2. This is the same thing, it's just not written in the same type of chart. So here's your value, here's your position. The term is actually the same thing as the position, or in other words, n. So from here to here, from value to value, it's increased by 2. It increases by 2 every time, which means to find my number, I'm going to multiply 2 times my term number, or my position, and that should give me my value, except that I have to accommodate for it not starting at 0. So 2 times 1 is 2. How do I get to a 3? I add 1. And I always check a couple of them to make sure I didn't make an error. So 2 times term number 2 should give me 4, but in the chart it says 5. So how do I get from 4 to 5? Add 1. 2 times 3 is 6, plus 1 is 7. 2 times 4 is 8, plus 1 is 9. So my rule is my value equals 2n plus 1, where again, n represents the term number, or the position in the sequence. This one is increasing 3 each time. So my first value should be 3. However, the chart says it's 1. How do I get from 3 to 1? Subtract 2. 3 times 2 is 6, but my chart says it should be 4. So subtract 2, and that tells me that my value should equal 3n minus 2. This is the same thing, it's just not in a chart. So when we look at this, this is our first term, second term, third term, fourth term. So how much is it increasing or decreasing each time? Well, this one, because it's on a number line, you add 2 to get there. And you add 2, and you add 2. So that means 2 times 1 should be 2, but the chart says it's negative 20. So how do you get from positive 2 to negative 20? You subtract 22. These are a little bit harder with the negatives, so always double check using 2 or more. 2 times 2 is 4, but the chart says it should be 18. So how do you get from 4 to 18? Subtract 22. So my value equals 2n minus 22, where n represents the position number. So from here to here, I am adding 3. So this should be 3 times my first position should give me 3. But my sequence tells me negative 9. How do I get from 3 to negative 9? I subtract 12. Double check another one. 3 times 2 is 6. How do I get from 6 to negative 6? I subtract 12. So again, my value is 3 times my position number minus 12. So that's all we have for today. We will practice with some more difficult sequences tomorrow. Your homework is on the next couple of pages. Make sure and complete it.